Olá a todos, tudo bem com vocês? Uma ótima noite. Muito obrigada aí pela presença de vocês. Gostaria de saber se vocês estão me ouvindo. Ok, obrigada, Tiago Viana, Michel Luz. Muito obrigada a todos. E hoje aí mais uma live aqui do canal, né? Um momento aí muito esperado por todos. Né? Todos aí, eu, por exemplo, aqui estou no clima de alta expectativa para o momento aí mais importante e complexo da missão OSIRIS-REx da NASA, né? Onde vai coletar amostras aí da superfície do asteroide mais temido por todos, o Bennu. Eu não sei vocês, né? Mas eu estou aqui na expectativa. Então é um momento aí muito esperado aí por todos. Marcos Rogério, boa noite. Boa noite, Fábio Dias. César Costa, Charles, João Evangelista. Tá sem som. Deixa eu acompanhar aqui. Eu acho que tá com som. Peraí. João Evangelista, para mim aqui o som tá ok. Para todos aí tá tudo bem? Bob Via Sul, para um beijo aí, um grande abraço aí para todos de São Paulo. Giovano Siqueira, obrigada. Um grande abraço aí para você. Boa noite, Vladimir Maia. Jean Alves, total, eu estou bem, né? E você, tá tudo bem? Chovendo um pouquinho, né? Aqui em Belo Horizonte está chovendo, mas está um clima muito gostoso, tá bem fresquinho, assim. Tô gostando bastante. Kleber Games, Oficial Play, um grande abraço aí para você. Boa noite, João Henrique. Galera, só um minutinho que eu já volto. Só um minuto. Olá, galera. Eu tô percebendo aí que vocês estão sem áudio, né, do vídeo. Eu estava aqui mexendo, mas parece que o áudio não retornou. Só um momento, tá? Que eu tô verificando aqui o que está acontecendo. Só um minutinho.
Boulders. So the team had to work with what we had designed for, which was that flat, sandy surface. If we were to try to sample on a rock, that actually presents a number of challenges of its own. For example, if we were to pick up a rock, it might actually just crumble away, and we wouldn't actually get a sample out of it. Also, some of these rocks might actually be a bit too stuck to the surface, and if we were to try to pry those loose, they might not actually budge, and we wouldn't actually even get a sample. So, these are all things that the team has to consider when designing something that's going to be operating millions upon millions of miles away from us here on Earth. So for now, back to you, Michelle.
Thanks, James. We'll be back to you more for later. Okay, now, I have been a Star Wars fan nearly all my life, and in one movie, Darth Vader said, rather famously, that asteroids do not concern me. But that is certainly not true for us this evening. We are all about asteroids here at the Mission Support Area in Littleton, Colorado. And we are bringing you live coverage of our attempt to collect a sample from the asteroid Bennu. Now, OSIRIS-REx is a one-of-a-kind spacecraft with an extraordinary team of engineers and scientists charting unexplored places. It was launched on September 8th, 2016. The vehicle has traveled over 2.2 billion miles on a complex route to reach Bennu. It's scheduled to deliver its precious cargo back to Earth in 2023. So now let's take a closer look at OSIRIS-REx.
Over 200 million miles away from Earth, NASA's OSIRIS-REx spacecraft is preparing for an ambitious sample collection attempt at asteroid Bennu. Before it makes its approach to the rocky surface, let's take a look back at some of the incredible firsts for this mission, which almost seem like something out of a Hollywood movie. This is the first asteroid sample return mission for NASA, and it could be the largest return from space since the Apollo astronauts brought moon samples back to Earth. While getting set to grab a sample, OSIRIS-REx has set not one, but 2 Guinness World Records. Its first for the smallest ever body orbited, and its second for the closest orbit of a spacecraft. This tight orbit has brought the spacecraft so close to Bennu that OSIRIS-REx's onboard cameras and laser altimeter have been able to image and characterize the asteroid's surface and shape better than Earth, our own moon, or any other celestial body. OSIRIS-REx has imaged Bennu down to 5 cm per pixel resolution, providing us with an unprecedented view into this rocky and gold-filled.
Oi, galera, voltei. Eu consegui aí consertar o áudio para vocês. Pronto, acho que está tudo ok, né? Vocês estão ouvindo agora. Ricardo Rodrigues, já estou aqui, Ricardo.
OSIRIS-REx imaged rocky ejecta that has been bursting off Bennu. This is the first time we have been able to observe the entire life cycle of a natural satellite ejecting off an object, entering into orbit, and returning back to the surface. Because of Bennu's extremely rocky surface, the team needed to adapt
Sinuquinha Manhaçu, muito obrigada aí pelo superchat de R$2. Muito obrigada.
This is the first time this approach has been used in space, and it will allow OSIRIS-REx to steer itself down to collect a sample from Bennu. And now, OSIRIS-REx is looking to set another first for NASA. Successfully collect a sample of an asteroid and deliver it to Earth in 2020.
Pois é, gente, eu vi alguns comentários, algumas pessoas estavam perguntando se vamos conseguir ver hoje as amostras do Bennu. Nós não vamos, conseguir saber hoje, né, só amanhã, a partir das 18 horas. A NASA vai divulgar, né, se conseguiu realmente fazer a coleta, se foi bem sucedida a coleta aí, do asteroide.
It's been an exciting day already, Michelle. We're well over 3 hours into the tag sequence, which is the pre-programmed set of commands that are already on the spacecraft. Earlier we departed our orbit.
Desculpa, gente, eu estava mexendo no áudio aqui, que eu deixei o áudio, tá dando retorno aqui para mim, então abaixei o meu áudio aqui do computador. Pois é, então só amanhã, né, que nós vamos ficar sabendo se foi bem sucedida aí a missão, né? O vídeo de hoje não vai mostrar em nenhuma imagem dessa coleta, né? Não vai mostrar nenhuma imagem assim, mas é mais para quem gosta realmente de astronomia, né, gente? Porque realmente é uma missão única e uma missão muito especial, né? A OSIRIS-REx ela é a primeira missão de retorno de amostra de asteroide dos Estados Unidos, mas não é a única, tá? No início do ano passado, tivemos a Hayabusa 2 da JAXA, né, que pousou e coletou aí com sucesso uma amostra do asteroide Ryugu. Eu não sei se vocês vão lembrar, quem acompanha meu canal vai lembrar. E ela retornará à Terra aí, mês que vem, não, perdão, vai ser em dezembro aí desse ano. Coletar amostras aí de asteroides são extremamente importantes para a ciência, né? Porque eles são relíquias, né, como falam, relíquias dos primeiros momentos aí da formação do Sistema Solar. Então, é muito importante, né, estudá-los. E além do fato, aí, no caso do Bennu, muitas pessoas, a gente fica com muito receio do Bennu, porque ele tem uma órbita próxima à Terra. E ele é um asteroide grande, de 500 metros de diâmetro. Mas ele é um asteroide que dificilmente causaria aí danos significativos ao nosso planeta, exatamente por ele ser um asteroide mais poroso, né? Como se pegasse um monte de entulho né, e juntasse assim, então ele vai se desfazendo muito fácil e isso é muito bom, né? Vamos esperar, aguardar aí se tudo der certo hoje. Vamos torcer para que tudo dê certo. Né? A espaçonave, no caso a Osiris, ela vai, no momento ali, ela vai implantar um braço robótico aí de 3 metros, que a gente chama de percam. Né? Ela deve gastar aí cerca de 10 segundos para coletar essas amostras, que deve ser em torno aí de 50 gramas. São partes, né, que ficam soltas ali no asteroide. Então, são poeiras, partículas. E se der tudo certo, né, teremos o retorno aí do asteroide BENNU, dessas amostras, em 2023, que é quando está programado aí para retornar à Terra. Vamos ver aqui os comentários. Espera aí, gente, que os comentários travou aqui, só um momento.
Also very difficult to take a sample in a very low gravity environment. So thankfully, we have the mastermind behind the device that's going to take the sample tonight, Lockheed Martin's Bo Beanhouse. Welcome, Bo.
Thank you, Michelle. It's great to be here.
Okay, so let's talk a bit about why working in this low gravity environment makes it tough to
Obrigada, Luciano de Oliveira. Fico muito feliz.
robotic claw or robotic arm and scoop something up, but that's not going to work in these conditions.
That's exactly right. The microgravity of Bennu provides a challenge of sampling that we don't normally face on Earth. You can imagine trying to use a shovel or a scoop on Earth, and the ground pushes against you, but the gravity keeps you on the ground. On Bennu, the surface gravity is thousands of times lower than
Pois
on
é,
Earth.
gente, eu estou verificando aqui, estava tendo uns probleminhas técnicos aqui. A minha preocupação hoje é a gente ficar sem internet aí no momento da live. Se isso acontecer, vocês me desculpem, porque foi ontem eu fiquei sem internet, porque chove, né? Chove e aí acontece às vezes a gente ficar aí sem conexão. Então, tomara que dê tudo certo, que a gente consiga transmitir até o final, né? Jean Carlos Castro, muito obrigada. Um grande abraço para você. Samuel Vida, de Moçambique, um grande abraço.
Partway down the arm, you can see 3 gas bottles. We'll use one of them today. This has high pressure nitrogen gas, which passes down the arm into the TAGSAM head itself.
157 pessoas assistindo o nosso canal nesse momento. Muito obrigada. Fico muito feliz. Tinha um tempo, né, que eu não fazia transmissão ao vivo aqui para vocês. Mas eu não poderia deixar aí de fazer essa transmissão de hoje, né? Realmente é muito importante, especial, e vocês sabem o tanto que eu gosto aí de asteroides. É claro que eu gosto deles lá no espaço, né, gente? Não quero que eles venham, que eles venham aqui para a Terra, não. Que eles fiquem lá. Obrigada, Master TV. Criatório, obrigada. Arnaldo, um grande abraço. Regiavane de Deus, boa noite, Lulu, obrigada, boa noite para você.
That's exactly right. When we were first designing this device many years ago, we were thinking we wanted to keep
Bernardo Santos, perdão, de São Paulo, Osasco, um grande abraço aí para você. Vote em Lulu para vereadora 11344. Não, tô fora. Não quero saber de política não, viu? Meu volume tá baixo. Gente, hoje tá uma loucura aqui hoje esses áudios, hein? Estão todos ouvindo aí meu áudio baixo, gente? Leonardo Lese, obrigada, Leonardo. Um grande abraço aí para você.
So most geologic material is irregularly shaped. So this rock is actually about 4 centimeters long in its longest dimension, but we were still able to collect this in a test on Earth. And that's because even though it's
Arnaldo Ramos, eu ainda não ativei o Seja Membros, porque às vezes eu fico preocupada de não ter tempo aí de enviar para vocês o conteúdo prometido. Então ainda estou pensando, sabe, se eu coloco lá o botãozinho Seja Membros. Várias pessoas me pedem para colocar e vamos ver. Mas obrigada. Mas se você quiser ajudar o canal, contribuir com o canal, eu tenho também o apoia.se, né? Muitas pessoas contribuem com o canal através desse site, então se você quiser contribuir, o link, eu deixo sempre o link na descrição de cada vídeo. Marcos Rogério de Barros, a gente quer ver você. Sim, eu tô com um probleminha aqui na minha câmera, já tem um tempinho, até tinha comentado com um dos inscritos. O meu celular não é muito bom, já tentei fazer um teste com ele assim, não fica muito bom. E é por isso que eu não tô fazendo aí os vídeos aparecendo, mas vamos ver. Se der tudo certo, né? Vamos ver se eu consigo comprar uma câmera. E aí eu vou voltar a fazer os vídeos como eu fazia, tá bom? Uma câmera aí, não é que seja cara, mas é um pouquinho, né? Mais cara. Então, no momento agora eu tenho outras prioridades, né? A gente tem família e tem filho, né? Então, mais em breve, tá bom? Desde quando você gosta de astronomia? Jadson Danda. Eu sempre gostei, na verdade, desde criança eu sempre gostei muito, gostava muito das aulas de ciência, de participar aí das feiras de ciência, eu sempre gostei bastante, desde criança. Mas há pouco tempo que eu comecei com o canal, né, que eu decidi realmente fazer esses vídeos falando sobre astronomia.
Here in the center area, we have Curtis Miller. Curtis is our NFT lead. He is watching natural feature tracking, and that is how we are navigating to the surface of Bennu today. So he is watching how NFT is performing, how many features we're matching, and how that system is working.
So I know natural feature tracking, like you're saying, is kind of keeping an eye on telling us where we're going, and I know we're going to get into that a little bit later in the show. But also it's important just to stay in communications with the spacecraft. So what about comms?
Yeah, absolutely. So right behind me here is Sierra Gonzalez. She's our real-time operator, or our ACE. She is working with our Deep Space Network partners. Currently, we're on a station in Goldstone and in Canberra, making sure we maintain our comm link. And our comm link is only 40 bits per second, so we're just bringing down...
Galera, tem uma presença aqui muito especial aqui do meu lado. A minha filha, Lorena, fala oi, dá boa noite aí pro pessoal do canal.
Oi, gente, boa noite. Eu sou a Glog Glue.
Ela fala Glog Glue porque ela tinha um canalzinho Glog Glue, acabou que a gente acabou não postando mais vídeos, mas ela tá aqui do meu lado acompanhando comigo a live aqui com vocês, né? Que ela adora ciência também, ela fala que vai ser cientista, né, minha filha? Então é isso, gente. Deixa eu só um minutinho. Deixa eu tirar ela daqui, senão ela quer falar também. Dando um beijo para todos.
Beijo, tchau. Boa noite.
Até mais, gente. Espera aí só um minuto. Nilson Alves está mandando boa noite. Silva, Lúcio, boa noite, Lorena. Fala boa noite.
Boa noite.
Só um minutinho, gente, que eu já volto.
All right, so we're inching ever so closer down to the surface of Bennu, but today we also want to hear from you. So you can check in on live updates at our Twitter account at OSIRIS-REx, or using that hashtag to BENNU and back across social media to get in on the conversation. In the meantime, a question I had when I first started covering the mission is, how do you even begin to prepare for a mission of this scale? I mean, when I first heard about OSIRIS-REx, it really seemed like something out of a big budget movie. But this is a reality. We're actually going to be trying to sample on an asteroid.
Oi, galera. Tirei ela daqui, porque senão ela vai querer ficar aqui falando com vocês aqui até o final da live, que ela gosta de falar. Pois é, Luciana, eu falo com ela. Cadê? Manda salve para Fábio de Minas Gerais, estamos vendo aqui. Um grande abraço, Fábio Viottini. Obrigada, Flávio Lemos, boa noite para você. Obrigada, Marcos Rogério. O som tá baixo. O meu som tá baixo ou do vídeo? Peraí, deixa eu verificar aqui, só um momento. Olha se melhorou o áudio.
How does the craft have enough fuel to return back to Earth from the asteroid? So we're looking to bring that sample back in 2023. And OSIRIS-REx's thrusters are actually powered by hydrazine, which is stored in a container on the spacecraft.
AMM, obrigada. Obrigada, fico muito feliz de tê-lo em meu canal. Que bom que você está gostando.
Microgravity environment, and it just requires a little bit of thrust to kick us in the right direction to collect the sample.
Agora vocês estão me ouvindo? O áudio aí melhorou? Sim. Obrigada, Marcos. Obrigada.
Thank you, James. Okay, so let's take a quick look at the simulation to see where we are. As you notice with the simulation, the spacecraft has its arm extended now, and it's on a slow path toward the surface. So as we get closer to the moment of contact, the drama starts to happen in slow motion. And this is to maximize precision and minimize unintentional surprises. So, speaking of surprises, there is one big aspect of the OSIRIS-REx mission that's all about preparing for the
acho que teve
unexpected.
alguém que me
And joining us to
perguntou.
discuss this is
A
NASA
OSIRIS
Planetary
ela
Science
foi
Division
lançada
Director, Laurie Mays.
em
Now, Laurie, you have kind of a
setembro,
dramatic
acho que foi setembro de
specialty
2016,
and a
isso
responsibility
mesmo.
that comes with your position at NASA.
E
You
chegou
actually
ao
learn about
asteroide
things like
em
planetary
dezembro de
protection.
2018.
Planetary protection or planetary
Eu acho que
defense
era
is
isso que alguém tinha
fundamental to
perguntado.
defending our planet from potential impacts. And Bennu is in a special class, and I think Dante spoke about this a little
Boa
earlier,
noite,
that,
Fabiano
Bennu is actually a
Batera.
near-Earth object, or a NEO.
Grande abraço aí
And
para
a NEO,
você.
a near-Earth object, is an asteroid or a comet that
Hamilton,
orbits the sun,
grande
much like our
abraço aí de
planets do.
Brasília.
But they're slightly unusual.
OSIRIS has reached the third and final natural feature tracking attitude. The spacecraft will hold this fixed attitude until
Igual estava falando, ele chegou, né, em Bennu em dezembro de 2018. Foi em dezembro, mês de 2019, que a equipe anunciou, a equipe da OSIRIS, né, ela anunciou o local de pouso escolhido, que é o Nightingale. Acho que vocês já ouviram falar, que é uma cratera, né, relativamente nova e do tamanho de uma quadra de tênis. Que é um local de pouso aí do asteroide para coletar as amostras, né? O asteroide BENNU foi uma grande surpresa, porque todos esperavam que teria como, né, pousar mais facilmente nele, mas aí perceberam que ele tinha muita pedra, muita rocha, né? E pedras e rochas grandes, altas e de tamanhos de prédio. Então não tinha um local, né? Como eles tinham planejado, o local anteriormente não era favorável, né? Então até que eles conseguiram decidir aí o local de pouso, né, em dezembro aí de 2019, que foi onde anunciaram aí que foi a cratera Nightingale.
A little bit is all you need.
Just a tiny bit.
So, I mean, that is really exciting. Now, I also understand that not all of the asteroids in the solar system are the same. There are different sorts, and NASA has some upcoming missions to study these different kinds of asteroids. So tell us a bit more about that, please.
Absolutely.
Leandro
Yeah, we know
Miguel,
that the
se está ao
majority of our
vivo mesmo,
asteroids are
sim,
found,
está ao
in the
vivo.
main asteroid belt between Mars and Jupiter. And in fact, we have a mission that's going to launch in 2022.
Ela
It's
vai
called
tocar o
Psyche.
solo,
It's gonna visit one of
já
the
Edson,
biggest,
por
asteroids in the
alguns
asteroid belt.
momentos,
It's
tá?
actually called
Ela vai
16
tocar por
Psyche.
alguns segundos, vai
And this
coletar as
mission, is
amostras
gonna arrive in early
e vai subir
2026
novamente.
and help us better understand if this asteroid is potentially actually the core of a planet-sized object. We also have other types of asteroids called Trojans that are clustered in two groups that lead and trail in Jupiter's orbit due to a balancing act of the pull of both Jupiter's and the Sun's gravity on them. NASA has a mission to those Trojan asteroids called Lucy. It's going to launch next year, next fall, about a year from now, and it's going to go visit several of these Trojan asteroids. We have a new mission called Janus, and we selected this mission through our Simplex
As
Small
informações
Mission
para a
program
gente
line.
aqui,
This
no
mission is
caso,
going to send actually two small
para os
spacecraft,
operadores
very
aí da
small
missão
spacecraft,
OSIRIS,
to
leva
two
cerca aí de
binary
18
asteroid
minutos,
systems and help us
tá, para que o
understand what it
sinal
is that makes
seja
these binary
recebido
asteroid
aí
systems
da
different from one
espaçonave.
another.
Tá?
And
E
so
as
studying
amostras
this full breadth
só vão saber
these
amanhã,
diverse
por
small
volta das
worlds will
18
continue
horas,
to help
né,
us
que eles
fill
vão
up the
anunciar
knowledge
se
gaps of how
realmente
our solar system actually formed and
foi
evolved over time.
conseguiu, né, a
So it
OSIRIS
seems with all these
conseguiu
missions coming up,
coletar
we're
aí
sort of in
alguma
a golden
amostra.
age of asteroid exploration. But then there's this other aspect of the OSIRIS-REx mission, which is the sample return. And it turns out that we're also beginning this golden age of sample return to it, and not just to asteroids.
O BENNU,
You're
acho que alguém
absolutely
tinha
right, and we're
perguntado,
really
o
excited
BENNU ele
about
foi
all these
descoberto
samples because they're
em
so precious and there's so
1999,
much science we can do
tá?
with them.
Ele
In
tem
addition to
cerca de
OSIRIS-REx,
492
we're
metros de
also
diâmetro,
partnering
como eu
with
disse
the Japanese
anteriormente,
Space
eu
Agency on
arredondei
their
para
mission called
500
Hayabusa
metros,
2, which is actually
né?
already
Mas
on its way back,
é um
bringing a
asteroide
sample
grande,
from Ryugu. They're gonna be
mas
coming
as
back to
chances
Earth in
dele
December.
causar
We're also
grandes danos
partnering
à
with
Terra é
Japanese
muito
Space
pequena,
Agency on another
tá?
mission of theirs
Pelo
that's gonna
tipo de
return a
material
sample
que ele é
from
feito.
Phobos, which is one of the two moons of Mars. And then finally, at the end of this decade, we're going to send a mission to Mars to retrieve the samples that are collected by the Perseverance rover, which is really, truly our first astrobiology mission from NASA. And it's focused on looking for finding potential life, ancient
O
life
BENNU,
on Mars.
ele
So
é de
sample
grande
return
interesse
is really important,
científico,
because it allows
porque ele é
us to
classificado
study
como
these
asteroide do
pristine
tipo
samples
B, né, o
back
que
here on
significa
Earth.
que contém uma
We can
grande
then take
quantidade aí de
advantage of our
carbono,
room-sized laboratories,
e tem, claro, que tem
all of this
outros, vários outros minerais também. E esse conteúdo de carbono de BENNU, ele cria uma superfície, né, no asteroide que reflete aí cerca de 4% da luz que é atingida aí pelo Sol. Então, assim, ele é bem escuro, tá? Para você ter uma ideia, né, o planeta mais brilhante do nosso sistema solar, que é Vênus, reflete cerca de 65% da luz do Sol. E a Terra reflete aí cerca de 30%.
Instruments that haven't been invented and to ask questions that we don't even know to ask yet.
That is just so cool. I mean, life is all about how we navigate unknowns. This is something that's happening in real time around us tonight. So it's reassuring to know that there's an organized plan that you're in charge of to help take some of the uncertainties out of at least one dramatic category. so Lori Glaze, thank you for joining us this evening. So good to see you.
Thank you so much for having me. I just want to add that it's been fantastic to watch the OSIRIS-REx mission so far, and I'm really, really excited for what's ahead tonight, and I want to say congratulations to the entire team.
Thank you so much.
Thank you.
Now, asteroids are not easily navigated. They're hard to see, they have low gravity fields, they're dark and rocky, and traveling around the solar system where everything is moving rarely means traveling in a straight line. Let's take a look at some of the big challenges the team has faced to get to this point.
Alguém me perguntou que ano, né, que essa sonda foi lançada, deixa eu ver quem foi. Ai, perdão, gente, eu perdi aqui quem foi que perguntou, mas ela foi lançada em 8 de setembro de 2016, lá do Cabo Canaveral, na Flórida.
We have never done this before. We're actually going to collect the sample and bring it back down to Earth for further examination by scientists.
In order to achieve that objective, the OSIRIS-REx spacecraft has been navigating around Bennu
Vamos
for about
torcer
the
aí
last
para que a
2
amostra,
years,
né,
studying it in great
se a
detail.
gente consiga
And also
conseguir
overcoming a
com
number of
sucesso aí a
challenges
amostra,
that Bennu
porque
has
realmente
presented. We
é
were
um grande
looking for
desafio,
locations
né,
on Bennu that were
coletar
50
amostras
meters in
do
diameter,
Bennu. Como eu
relatively
disse,
flat,
é
and covered with
difícil
fine
pousar
grain
nele,
material. And by
né?
fine grain material, I mean stuff that's the size
Ele
of a
tem
dime.
muitas rochas,
We
né?
realized that there
Então
were no
é
sites on Bennu that
complicado.
even came close to
Então
meeting
vamos
this
ver se
criteria.
consegue
Everywhere we
hoje
looked
aí
was too
fazer a
small,
coleta. Se
covered
não
with boulders.
conseguir, ainda
So we
tem
actually had to fly a number of
Bennu.
additional close passes over the asteroid
A
and
Osiris
rethink our
conseguirá.
entire plan for
Desculpa,
grabbing
gente,
the
eu tô
sample.
aqui gaguejando, porque minha filha tá
After the
ali.
additional
É
observations
difícil
of Bennu,
transmitir
we had to
com
down select
criança,
the
viu,
4
gente?
sites, and then go
Perto.
back and
Toda
survey
hora ela
those
tá me
sites even
chamando ali,
further to
perdão,
select
tá?
the final primary sample site.
Pois, como eu estava dizendo, é difícil, né, conseguir amostras do Bennu por conta disso, mas caso não consiga hoje, a Osiris terá mais aí 2 chances de coleta, tá?
Natural feature tracking works a lot like the human mind in that we pick up landmarks along the way. As we descend, we look at features on the ground. We program the computer to recognize certain features. It takes a picture.
Fábio Viottini, pode ser, Fábio, por isso que está sendo coletadas essas amostras para ver a composição química, né? E quem sabe descobrir coisas aí muito importantes aí para nós. Asteroide do tipo do Bennu, ele é considerado aí muito importante, né? Porque ele pode conter informações sobre a formação do sistema solar, né? Há bilhões de anos atrás, sobre formação, sobre como sobre a vida, né? Aqui na Terra, sobre a formação do nosso planeta. Então, não é à toa, né, que essa missão foi lançada ao Bennu, já que é um asteroide carbonáceo.
We don't only get one shot at tag, we actually have 3 nitrogen bottles on board the spacecraft, so we can potentially do 3 tag attempts if needed. We go through several what-if scenarios, and this is how we actually prepare for a lot of our contingencies.
So we've had to look all around the surface and identify the rocks and boulders that if the spacecraft were to tip over up to 25 degrees, it could come into contact and be damaged.
We had to develop a hazard map, which we program into the computer and says, if you're getting too close to those hazards, we'll do a wave off, we'll back away from the asteroid, and we'll come back and do this another day.
Everything might work perfectly. We come down, we touch the surface just where we want to, we fire the gas bottle, but the area we contact is covered in large rocks. Those rocks would prevent any fine grain material from being stirred up and captured in the tag SAM head. Another similar scenario is if the tag SAM were to touch on the edge of a boulder and become tipped up. In that case, when the gas bottle fires, much of that gas escapes out the side, not churning up the material that we want to capture. The day of tag is going to be really exciting, but the excitement for our team doesn't end there.
We have to verify that we have a proper sample.
First, we're going to image the tag SAM head by sticking it in front of one of the cameras. Then we're going to do a maneuver called the sample mass measurement, in which we stick out the arm and we spin the spacecraft in order for us to decide if we've collected enough mass to be able to stow the sample and return home, or if we have to try again.
This is the culmination of a lot of work. It's probably one of the most exciting missions that I've worked on.
It is really exciting to know that we're finally going to be able to touch the surface of the asteroid and collect the sample to return back to Earth.
So step back for a moment and realize that tonight's events are exceedingly rare and historic. Humanity has only landed on a few different bodies in the solar system, and actually retrieving a sample is even more rare. So luckily with me tonight are some of the people that know better than anybody all the challenges that it took to get here. So let me introduce Mike Moreau. Mike is the OSIRIS-REx Deputy Project Manager at the Goddard Space Flight Center, and Coralie Adam is Tag Navigation Manager at Kinetics Aerospace. So welcome, Mike and Coralie. How you guys doing?
So excited.
So excited. We're less than a half hour from tag now.
Yeah, you can feel the energy all building. So I should mention at this point that it's possible, you've been hearing this before, cheers from the MSA. So can you give us a sense what's going on right now?
Yeah, so every few minutes, a navigation camera image is taken by the spacecraft of the surface below, and it's sent to the natural feature tracking system. And that system identifies features in the image and sends a signal back to Earth that it was successful.
Position uncertainty is 0.5 meters.
And the team celebrates. It tells us we're on track to our next target and on track to tag.
Absolutely. So now, clearly there's a lot to talk about in terms of the mission, but once again, you had to do all of this in the midst of this COVID-19 pandemic. So were there any mission expectations that changed? How did you deal with that?
Yeah, for sure. I mean, as the whole world was coming to grips with the pandemic in the March timeframe, this team was in the midst of preparing for our first tag rehearsal, the checkpoint rehearsal that would take the spacecraft only 65 meters above the surface. So we had to rethink the entire way in which we were going to do that rehearsal with only a skeleton crew here in the building and with many of our team members remote, as Sandy mentioned before. Today we have people literally all over the building monitoring, also at Goddard Space Flight Center and at the University of Arizona watching this event today. But thankfully we got through checkpoint rehearsal in April and match point rehearsal in August.
And all those special considerations, they're still going on around us today, right?
Yeah, I mean, you could see people spaced out in the MSA when you were over there. And, you know, we had more time to prepare for TAG in order to accommodate that and get everyone into the building here today. So I'm just incredibly proud of our team for, you know, their efforts to keep the project on track for TAG in spite of all of these challenges.
Absolutely. So I know NASA's famous for having to deal with unexpected situations, and this COVID-19 thing is kind of a different flavor of unexpected situations. So we're going to deal about that. Okay, so now let's talk more about the challenges of TAG that we introduced in the video segment. So Corley.
Right, so you've seen that Nightingale site is an extremely challenging spot to navigate into. There's boulders all around it. This is totally different than how we originally designed the system to target a 50-meter diameter area. Nightingale is 10 times smaller than that. So it required the whole team to rethink how to safely navigate into this contact with the surface, and we had to come up with some new ideas.
Yeah, so the original navigation approach used LiDAR, or laser-based navigation, to take us to the Nightingale crater. But when we saw what Bennu looked like, we realized we had to switch to a vision-based approach, and that's the NFT system that you've been hearing about.
Yeah, so the Kinetics navigation team has spent the last 2 years learning how to navigate around Bennu using optical navigation techniques very similar to what NFT is doing on board the spacecraft today. So Kinetics worked with scientists and the Lockheed Martin NFT team to map the surface of Bennu.
OREX has processed its next image. Position uncertainty is 0.5 meters.
Really honing in. So we mapped the surface of Bennu to unprecedented resolution of 2 centimeters per pixel, which is better than what we've done on our own Earth and Moon. So it was a huge Herculean effort to get to this point where we're comfortable handing the maps and the keys over to the spacecraft to get us down into this small site today.
Absolutely. So I guess right now it's time to say goodbye to you guys. The best of luck for today. I'm really excited, and it's great to be with you guys.
Thank you, Michelle.
Yeah.
Thank you.
So right now, I think probably the best thing to do is to check in with Gary Napier. So I guess we're going to go back and see how things are going back there. So to Gary.
So things are going really good right now, Michelle. We're actually going to talk to Heather Enos here.
OREX
the
MSA
Deputy
on OREX
Principal Investigator
OREX
for the
solar
OSIRIS-REx
arrays are
mission
in the
out of the
Y-wing
University
configuration.
of Arizona. Thanks for joining us, Heather.
Hi, Gary.
So what's really interesting, Heather, is that you actually feel that, you know, long missions like this are really important. I mean, you go from design to build, but operations is really quite a while. That it's actually really important to involve that next generation and kind of bring that generation up, correct? Talk to us a little bit about that.
Absolutely, Gary, you're right. All the way back from when we started planning this mission, OSIRIS-REx, we recognized it's a long duration mission. And although that presents challenges for retaining your key personnel, we actually took it as an opportunity to use this mission to train our next generation of students and science engineers and scientists. A good example is we had one of our science instruments is called REXUS. It's an X-ray spectrometer built by a team of students at MIT and Harvard. So real hands-on.
That's really interesting. I mean, I understand you also have some folks that actually were students and came onto the team later?
Yeah, so being at the University of Arizona on a PI-led mission, we have had hundreds of undergraduate and graduate students working on this mission over the course of the last decade. And 2 of our students that started off as students are actually 2 of our navigation team members. That's Dan Wibben and Eric Sarr.
Wow, so they're on console.
They're on console right now. Yeah, they are.
At this time,
That
NFC
is
has
so
computed the checkpoint and match point burn updates to correct for errors in the trajectory accumulated since orbit departure. Checkpoint burn in 2 minutes.
the checkpoint turn in 2 minutes. We're going to throw it back over to Michelle because I know this is an important update for her. So Michelle, thanks. Back over to you.
Thanks, Gary.
Well, absolutely. So, Dante, tell us what this important milestone checkpoint means.
This is a really important part of the mission right now. So we've been hearing about natural feature tracking and how it's processing these images.
MSA on OREX ops. OREX has processed its next image. Position uncertainty is 0.46 meters.
Right, so what it's doing with that information is it's calculating how it's going to fire its thrusters for this checkpoint. When we left orbit, we were on a trajectory that would take us over the surface of the asteroid, and if nothing else happened, we would safely fly past Bennu. Once we fire the thrusters for the checkpoint maneuver, we're actually going to start descending down towards the asteroid surface, so this means we're going to be on our way to make contact. So natural feature tracking has been doing nothing but calculating this maneuver since we started taking images.
So this is one of the big deals. This is one of the big milestones coming up.
This is huge.
Yeah.
Absolutely.
I know that as we look at the simulation, there's an interesting configuration the spacecraft is in. Oh, I see the thrusters firing.
That's right. You can see we would expect right now on the spacecraft the thrusters to be firing, so we're going to be paying close attention to Dale Howell to let us know we've gotten telemetry back to telling us that maneuver has succeeded.
In the meantime, if you want to tell us a bit about the configuration it's in, go ahead.
Yeah, we heard Dale call out earlier that the spacecraft was in the Y-wing configuration. There we just reconfigured the solar arrays to get them up away from the asteroid surface, basically to protect their active areas from any dust loading that might be kicked up during the tag event.
It's another excellent Star Wars reference.
That's right, always. You can also see here in the simulation the Nightingale sample site, now down in the lower corner here. This is our target. This is what we're trying to get into with that spacecraft. So.
Now, it looks like there's a lot of boulders around that.
Yeah, as we've said, generally the surface of Bennu is rough and rugged and covered with boulders. Nightingale really does stand out as a pretty unique, interesting area on the surface.
How you doing?
Doing pretty good. Paying close attention to that call out, waiting for Dale to tell us that checkpoint has occurred.
Absolutely. So what we're waiting for right now is the call out that checkpoint has occurred, and the OSIRIS-REx spacecraft has begun its descent towards the asteroid surface.
Right, any time now.
And it's probably worth mentioning.
OREX MSA on OREX ops. Checkpoint burn has completed.
Okay, we're heading down towards the asteroid surface at this point.
Oh, wow. Oh, wow. Okay, well, you know, I guess the next thing that comes up is going to be this match point maneuver. So that's the next big milestone for us.
That's right. So we've got one more firing of thrusters with the spacecraft to get us lined up for the sample acquisition event. We call that the match point because what we're doing there currently as we're flying over the asteroid surface, in fact, it's the asteroid surface that's rotating underneath us. And when we fire thrusters for match point, we're doing that to match that rotational velocity so that the spacecraft becomes station keeping essentially over that Nightingale sample site.
Absolutely. All right, so I think we have a little bit time now to turn to our social media desk. So James, what's going on in social media?
Yeah, Michelle, it's super exciting. You just heard that checkpoint burn confirmed. We are now just very, very close down to the surface of Nightingale. And you guys have been really excited over on social media too at that hashtag to Bennu and back. Lots of great messages rolling in here. Someone's really excited for our little robot friend to go rock hunting on the surface. We had someone who actually attended our launch back in a couple of years ago at Cape Canaveral and are now watching the broadcast live with us today, excited for that sample collection event. We have Philip who kind of puts it in perspective for us here. He says, this is amazing and extremely difficult in so many ways. Bennu's orbit, spin, inclination, the orbital mechanics of this long mission are just astounding. I can only imagine how many orbit simulations have been made here on Earth. It really is a crazy mission, and we also have our animal friends, our pets, cheering us on here as well. Bennu is rough from this couple of our pets here, really excited. So we're now just minutes away from that match point burn, and for that, I'll kick it back to you, Michelle.
Okay, excellent. So, you know, just a few minutes ago, Dante, you were saying that this landing site is sort of a unique area on the asteroid. Tell us about this site.
Yeah, we spent an enormous amount of effort selecting the area on this asteroid surface where we wanted to get the sample from. And we kind of divided our analysis up into 4 different categories. First, we were looking at the deliverability. And this was a real challenge because, as we've seen earlier in the broadcast, the original guidance accuracy was 25-meter radius, and we're trying to get into an area that's 10% of that size. We have solved that problem with our amazing natural feature tracking solution, and as we've heard, that's worked really well, and it has updated its checkpoint and its match point maneuvers on board based on that information. That gets you down to the surface of the asteroid. So the next thing that we have to worry about is maintaining spacecraft safety. There's a lot of hazards on this asteroid surface, things that could damage a critical component, and we decided to focus safety on the things that were needed to get the sample back to the Earth. So there were certain things we could lose at this point in the mission if they didn't fulfill that objective. We still have some upcoming major milestones that help us maintain that spacecraft safety. Now natural feature tracking is going to be switching over to calculating the contact point on the asteroid surface. And it has a piece of software on board called the hazard map. It's actually determining, is the location that I'm going to touch down on safe, a green area on that hazard map, or is it potentially hazardous, a red area on that hazard map? So as we get closer to the asteroid surface, a key moment is the 5-meter crossing. That's when the spacecraft makes that decision. Do I continue down to collect the sample, or do I back away and live to tag another day? After that, you've got down there, your spacecraft is safe. There's got to be something for you to pick up. Earlier in the broadcast, Bo Bierhaus showed us the size of particles that TAGSAM could actually collect. So we had to map the Nightingale area and other potential sample sites well below that 2-centimeter resolution. And in fact, we got 3.5 millimeters per pixel all over the Nightingale sample site. And we were really excited to see lots of particles of that size. And of course, the final parameter that we were looking at was the scientific value. And I can tell you the good news is any sample from Bennu is scientifically valuable. We've seen these hydrated clay minerals, we've seen organic molecules, carbon-bearing minerals all over the surface of the asteroid, exactly the kind of material that we're hoping to bring home.
So I understand the next big milestone we're looking for here is something called match point.
That's right.
So what happens at match point?
Match point is the final maneuver that the spacecraft performs by firing its thrusters. And that's where we become centered over the Nightingale sample site and begin that final descent down to the asteroid surface. And the spacecraft is solely focused on its safety calculation and the decision on whether or not it's going to proceed down to collect that sample.
Of course, the amazing thing about match point is that the asteroid itself is actually rotating. So when we go to match point, the spacecraft has to match the rotation of the asteroid so it comes directly down onto it.
That's right.
So how fast is Bennu rotating?
Bennu has a rotation period of 4.3 hours. So that's basically the length of the day on the asteroid. On Earth, the rotation period is 24 hours, which is why a day on Earth is 24 hours long. So that translates, because Bennu's a pretty small object, as we've seen, 500 meters or about the same size as the Empire State Building. At the equator, the surface is moving at 10 centimeters per second. And it actually gets slower and slower as you go to higher latitudes. By the time you get to the North Pole, it's 0. Nightingale's pretty far north, so it's actually much lower than 10 centimeters per second. And that just kind of shows you the delicate precision nature of this mission. You know, we've got to get very low thrust maneuvers, very delicate, very slow approach to the asteroid surface. Everything kind of happens in slow motion when you're operating in a microgravity environment like Bennu.
So what's the next critical milestone after match point?
After match point, we're going to be looking for the natural feature tracking system coming back online, taking those images and additional correlations and precision on its knowledge of its position. And we might expect it to actually jump up. We've been hearing natural feature tracking uncertainties on the order of half a meter. It may go up a little bit
OREX
as it goes
NSA
through.
on OREX Ops. OREX natural feature tracking system has resumed processing. Position uncertainty is 1.6 meters.
So you can see there we went back to 1.6 meters. That's because we went through the checkpoint maneuver. So whenever you impart a thrust like that, it adds uncertainty into the system. And we're seeing that with the natural feature tracking system right now.
That is so exciting. Okay, so we're going to introduce, actually, the Associate Administrator of NASA, Dr. Thomas Zurbuchen. Thomas, thank you for joining us.
So glad to be here with all of you.
It's an exciting time, Thomas.
Happy birthday.
Thank you.
That's right. Yesterday's his birthday. Yeah, that's right. Happy birthday. So, I guess, everybody here is aiming for this point in time called, this TAGSAM. But it turns out that there have been a lot of friends, a lot of colleagues that have helped get us to this moment. So, who's been along with us on this journey?
Well, look, I mean, there's a number of course, domestic partners, many of them around here. You talk to some of them, but there's also international partners. And the Canadian Space Agency provided the laser altimeter, which is an important instrument here. And of course, we have a partnership with JAXA. What we're going to do is actually share the samples from Ryugu, from Hayabusa 2, with OSIRIS-REx once it's back for maximum science. And that's really what international partnerships are about.
So this is a big mission for NASA, but it turns out that there are many different kinds of partners in a mission like this. Give us a sense of the range of partners that we have.
Well, look, I mean, it starts with the University of Arizona. That's where the leadership is, and with you there and your entire team. But NASA Goddard Space Flight Center is a critical partner with managing, of course, especially also working with Lockheed Martin, who really, you know, with that team deserves a lot of credit, and Kinetics, which was already introduced, as well as many others. You know, if you really look, so often missions like that touch many, many states around the United States.
Absolutely. So, Thomas Zurbuchen, thank you for joining us, and we will see you later on in the program.
How do you feel, man?
I'm pretty excited. This is the final like 10, 12 minutes here for contact. I feel really good. The team's in high spirits. As you and I talked about earlier this week, we have done everything possible to make this today a success.
Exactly right. And you know, your mind is already out there, and the spacecraft is already on the way out in real time. Can you imagine that, right?
It's good actually to point out whatever has happened with TAG has already happened. We're well past that 18.5-minute one-way light time.
Absolutely. Hey, congrats. Let's continue doing this.
Yeah, we'll see you later. Thank you, Thomas.
Yep.
Oh, wow. Okay, so we're coming up, I know, on the critical point of match point. So at what point will we know that we really have a sample?
That's a great question. We're not exactly sure what's going to happen right away. We'll know if we made contact with the asteroid surface today. We'll know if the gas bottle fired, and we know that we backed safely away from the asteroid. But we actually have a lot of work to do over the next week or so. We'll take a look at the images that we were acquired during contact with the asteroid surface, and then we'll go into a different imaging campaign. We're about 30 seconds from match point, so we're going to keep our ears open for that critical call out from Dale.
OREX MSA on OREX Ops. OREX has processed its next image. Position uncertainty is 1 meter.
All right, we're back down to a meter positional uncertainty. That's great news. So back to sample verification. We will, after we're well away from the asteroid and everything has kind of settled down, we have that robotic arm. We're actually going to use that to put the TAG SAM head into the field of view of SAMCAM. And we can look not only at the top of the sampler head like we're going to get with the images today, but we can actually turn it around and we can look at the base of TAG SAM. We have, in addition to the gas stimulation, we have contact pads. Simply by making contact with the asteroid surface, we think we can pick up fine-grained particles less than a millimeter or so. But basically, we're going to be looking for any evidence of asteroid material on or inside the TAG SAM.
Now, obviously, you don't want to go all the way back to
OREX
Earth without...
MSA on OREX Ops. Match point burn is complete.
All right. We're heading down. We've got about 10 minutes before contact with the asteroid surface.
Oh, wow. So I was about to say, so obviously you don't want to head back to Earth with not much sample. So how do you know how much sample you actually got?
There's an incredibly clever physics experiment that the team has designed here called the sample mass measurement. So what we're going to do is we're going to place the spacecraft arm out to the side of the spacecraft. So when it's in sampling configuration, it's actually pointed above. For this, we point it out in the other direction, and we kind of spin the entire spacecraft around. And we're measuring a property called the moment of inertia. We have actually already done this prior to initiating the TAG sequence today. So we know what that property is when the TAG SAM head is empty. Now we're going to be able to do it, hopefully, when it's full of asteroid regolith. So we're only looking for small differences in this property as a result of this experiment. And the precision, just like everything on this program, is phenomenal. We're talking tens of grams of precision on a measurement on a spacecraft hundreds of millions of miles away that just picked up this asteroid sample. The minimum that we're looking for is 60 grams, or about 2 ounces.
MSA on OREX Ops. Attitude control system has transitioned to touch and go mode.
Right, spacecraft's getting ready to make contact with the asteroid surface here. So the sample mass measurement will tell us if we have 60 grams or more of material, and that'll happen on Saturday later this week.
Excellent. Okay, Dante, this is it. You know, the engines have given us a push in the right direction, and OSIRIS-REx is on course to make touchdown on an asteroid. So we're going to listen to the flight controller calls from MSA, but before we actually touch the surface, it's a great time to visit our social media desk again. So, James, what's going on?
Yeah, thanks, Michelle. So you've been hearing those call-outs from Dale over the loudspeakers about those NFT images processing. It'd be awesome to actually grab a camera and make the trek out to Bennu to photograph it up close in person. But, you know, as we've mentioned, Bennu is a little bit far away from us right now, on the order of 200 million miles away. But don't worry, here's something OSIRIS-REx can deliver to you right now from the comfort of your own home. If you're on Instagram, you can head over to @NASA Solar System, we have 2 AR filters that you can use on your social media stories. This first one's called OSIRIS-REx in You and features OSIRIS-REx playing tag with Bennu around your head. The second one is called To Bennu and Back and allows you to place an asteroid wherever you are, at home, at school. Bring an asteroid with you. So I understand we actually have a question coming in from Instagram from Mauricio, who asks, how do you manage the force back from touching down? I mean, the moment the spacecraft touches the surface, it should experience a similar force in the opposite direction. How do you manage that? Well, thanks Mauricio. So the team actually thought ahead for this one when designing that sample arm. They actually added this spring-like mechanism to it that you can think of a bit like a pogo stick. If that sample arm were rigid, when contacting Bennu, it would stop its downward motion, and when firing the gas bottle to stir up a sample, we would just kick right back off into space, as Bo Beer has. How do you manage that? Well, thanks Mauricio. So the team actually thought ahead for this one when designing that sample arm. They actually added this spring-like mechanism to it that you can think of a bit like a pogo stick. If that sample arm were rigid, when contacting Bennu, it would stop its downward. How do you manage that? Well, thanks Mauricio. So the team actually thought ahead for this one when designing that sample arm. They actually added this spring-like mechanism to it that you can think of a bit like a pogo stick. If that sample arm were rigid, when contacting Bennu, it would stop its downward motion, and when firing the gas bottle to stir up a sample, we would just kick right back off into space, as Bo Beer has. How do you manage that? Well, thanks Mauricio. So the team actually thought ahead for this one when designing that sample arm. They actually added this spring-like mechanism to it that you can think of a bit like a pogo stick. If that sample arm were rigid, when contacting Bennu, it would stop its downward motion, and when firing the gas bottle to stir up a sample, we would just kick right back off into space, as Bo Beer has. How do you manage that? Well, thanks Mauricio. So the team actually thought ahead for this one when designing that sample arm. They actually added this spring-like mechanism to it that you can think of a bit like a pogo stick. If that sample arm were rigid, when contacting Bennu, it would stop its downward motion, and when firing the gas bottle to stir up a sample, we would just kick right back off into space, as Bo Beer has.
We're going to start looking at those later tonight and have them available for everybody tomorrow morning. So this is just a simulation of the field of view of the SAMCAM, the sampling camera, part of our OCAM's camera suite. It has a clear shot of the TAG-SAM collector right in the middle of its field of view. You can actually see the lower end of the TAG-SAM arm here.
OREX MSA on OREX off. OREX is descending below 25 meters.
Okay, we're getting really close. And I want to remind you, it's the 5-meter crossing.
Yeah.
That's the really critical one. We're only a couple minutes away from that. So the spacecraft has one key decision left to make. It's calculating right now the probability that it's going to come down either on a hazardous area, as we defined on that hazard map, or in a safe area. So we may, at 5 meters, the spacecraft may decide that it's hazardous and it's going to back away, allowing us to live the tag another day. So to me, all my senses are on that call out right now.
Yeah.
I really want to hear that we are go for tag, so that's just a couple minutes away here.
And of course, remember that that was planned for. That
right.
It has to know it's safe, otherwise it's going to back up and try again another time.
That's really how we solve the amazing challenges that this asteroid surface presented to us. You can see here that this is a pretty daunting terrain that we're coming down here. There's giant boulders all around the Nightingale site, even some large rocks inside the crater that we do not think the spacecraft would survive, at least with the ability to return back to Earth if it made contact. So it is there to protect itself first and foremost. Safety is always first, but we're feeling pretty good. Everything's gone really well today, so I would say things are looking great for a tag, but of course the spacecraft is the one that gets to make that decision.
It's just amazing. We've been rehearsing this event, all week long, all the different mission calls and milestones, but then to actually be here tonight and realize that this is going on 200 million miles away.
That's right, yeah. I'm pretty excited.
So, I mean, there were obviously a lot of firsts in this mission.
OREX MSA on OREX Ops. OREX has processed its next message. Position uncertainty is 0.5 meters. Predicted tag lateral offset is 1.7 meters. Hazard probability is 0%. Tag lateral velocity is 0.2 millimeters per second.
Oh my God.
Tag vertical velocity is 10.2 centimeters per second.
That sounded really good.
Yes.
So it sounded like the hazard map calculation looks really good. That we're coming down in a green area. We're going to make contact with the asteroid surface.
Wow. So remember how historic this is NASA's first mission to retrieve a sample from an asteroid, a pristine part of the solar system. Just look at that animation now. So we're looking at
looking at the team. I think I think we can see everybody is laser focused on what this spacecraft's going to do. So I say let's let this play out. But those calls were really great. That was great news from Dale.
Yeah. Even more accurate than we'd hoped for in some cases.
Everybody seems happy.
Yeah. So I guess, there were obviously a lot of firsts in this mission, and there was a time when you said, a lot of what ifs, basically. I mean, what if we could actually send a spacecraft to an asteroid? What if we really could bring back a sample of the solar system from billions of years ago? Did you remember where you were when those what if
OREX
questions?
MSA on OREX Ops. OREX has descended below the 5-meter mark. The hazard map is go for tag. Contact expected in 50 seconds.
We're going in. We're going in.
Touchdown declared.
All right.
Sampling is in progress.
Oh my gosh, we're there, folks. That was amazing. I mean, I don't know if you saw the team here, but they just kind of blew up. They went from being steely-eyed to like celebrating the Super Bowl. So, it's all good. This is amazing. So congratulations, everybody. I know that Dante and Dr. Zabrukin are right here. And Dante, you somehow got over here pretty quick.
I sure did.
Congratulations. How you guys feeling?
Transcendental. I mean, I can't believe we actually pulled this off.
But I'm so excited about the team. Hey, do you mind if I just bring up something?
Please.
Our friend Mike Drake is with us right now.
That's
the
right.
guy who came up with the mission at the beginning, and we're thinking of him. He's no longer on Earth, but I feel him right here.
I agree. He's with us today, and I know he's incredibly proud of this team and everything we have accomplished. This is history. It's amazing.
God, I can barely speak. I'm like shaking. How about you?
Absolutely. It's almost hard to process everything that's happening right now. It's overwhelming pride in this team and everything we've done to get here. I couldn't really have anything better to say about this group of people.
All safety systems, I can confirm that the backaway burn is...
OREX MSA on OREX Ops. Sample collection is complete, and the backaway burn has executed.
All right.
We're on our way back.
Now, Dante, that was actually a really important call. We were celebrating on the tag, but that was actually probably even more important call. Why is that?
The pyro bottle's fired, so tag SAM operated. The backaway thruster's fired, so we're safely moving away from the asteroid surface. The spacecraft did everything it was supposed to do. So we did it. We tagged the surface of the asteroid, and it's up to Bennu now to see how the event went.
What does this mean to NASA?
Oh, I mean, this is key milestone of this. Now it's a few days, right? To figure out how much we got of this amazing sample that we're thinking about for decades. But I think this is just, I'm so proud of this team. Hey, team.
Oh, my goodness. Oh, my goodness. Well, I got to tell you, this has been a fantastic day, a fantastic journey. We're so proud of both of you for being here and supporting that team. We're going to get back over to the stage and Michelle, but some really good news. So back to you, Michelle. Thank you.
This is one of those moments we're all aware of COVID-19 because I want the hugs and the high fives and everything, but we're all going to keep each other safe. There are lots of super excited people all over who want to share in this moment and share their congratulations.
No kidding.
So let's take a moment to hear a few words from 3 institutional leaders who couldn't be here tonight, but they're cheering on the team on behalf of so many supporters.
Hi, everyone. Dennis Andrusick, Goddard Center Director. I am just so excited that OSIRIS-REx is collecting a sample from the surface of Bennu. The tag is just the pinnacle of the mission so far. Getting the sample back to Earth is obviously going to be the great event of the entire mission. But I got to congratulate Dante. You and your team, your project management skills as a PI, just superb. Rich, the operations team, for getting us to where we are, and Lisa Callahan for the awesome Lockheed Martin team, and getting OSIRIS-REx to where we are. And building a great spacecraft and returning it to Earth. Go OSIRIS-REx.
Today's an exciting day. As OSIRIS-REx begins its descent to Bennu, the nation is looking forward to the news of a successful tag event. OSIRIS-REx team members have been working on this project for more than a decade, and the work being done is hard, and it's complicated, and it's necessary. Understanding the makeup of Bennu will help us better understand our universe and how to protect our most important asset in space, Earth. I want to wish the best of luck to the entire OSIRIS-REx team, including our partners at the NASA Goddard Space Flight Center, the University of Arizona, and especially the mission operators and engineers right here at Lockheed Martin. Go OREX!
The University of Arizona is incredibly proud of its long tradition of excellence and leadership in space exploration. I'm thrilled to see the OSIRIS-REx's missions achievements carried this tradition forward today with NASA, Lockheed Martin, and all of our incredible partners.
Congratulations to all of the OSIRIS-REx mission team members. You have shown the world how our determination, creativity, and talent can advance the capabilities of our entire nation. And I can't wait for the amazing science we will see with the sample return in 2023.
Okay, well, we are here live after some excellent news. I'm here with an exultant Dante Loretta from the University of Arizona. So one more time for our audience out there, explain when we know we'll have a sample.
A little overwhelmed right now, Michelle, I have to say. It's been pretty intense several minutes here. I can tell you that everything went just exactly perfect, which is kind of the hallmark of this team. We have consistently beaten expectations over and over again. We have overcome the amazing challenges that this asteroid has thrown at us, and the spacecraft appears to have operated flawlessly. We made it down to the asteroid surface. We were in contact. The gas bottles fired. We don't know how long we were in contact with yet. That's some reconstructed information that we're going to have to put together over the next few hours as the data come in. We backed away successfully from the asteroid surface. The team is exuberant back there. Emotions are high. Everybody is really proud, and we have some work to do to determine how much sample that we have collected. The next thing that I'm going to be looking for is once the spacecraft cools off, it probably got pretty warm as it approached the asteroid surface, so it needs to get rid of some of that excess heat. It's got to get those solar rays back onto the sun and get power positive. Once it's stabilized, it's going to point that high gain antenna at the Earth, and we're going to start bringing that data back. And those SAMCAM images are going to tell us an enormous amount of information about how the events of today went. We're going to be looking at a whole series of images as we descended down to the surface, made contact, fired that gas bottle, and I really want to know how that surface responded. We haven't done this before, so this is a new territory for us. And the whole science team, I know, is really looking forward to that information. For one thing, it'll tell us the likelihood of sample collection, kind of a probabilistic assessment. Probably be a lot of science that comes out of that as well.
Yeah, well, listen, I know you want to be back there with your team. It's going to be a long, hopefully happy night for all of you as more data comes in. Thank you so much. It's been such an honor to be with you.
Thank you. Thank you, everybody, for a great evening, and kudos to this team. It's an amazing experience.
Oh, wow.
And in history, was made tonight.
Absolutely. So, you know, what we're going to do now is actually take a closer look at this beautiful terrain that we've actually sampled. We've identified over 1 million asteroids in the solar system. But remember, Bennu is what's called a NEO, a near-Earth asteroid. So instead of orbiting in the main asteroid belt between Mars and Jupiter, it has an orbit fairly similar to our own planet, Earth. And it not only gets our attention because it's so close to Earth, but also because we believe it may be one of the older bodies in the solar system with a wealth of information about how the solar system and life began. Let's take a closer look at the subject of all of this activity, all of this joy tonight.
Thank you.
Let's take a tour of Bennu.
In December 2018, after traveling for 2 years, 101 days, and over 1.2 billion miles, NASA's OSIRIS-REx spacecraft arrived at its target, near-Earth asteroid Bennu. OSIRIS-REx is the first mission to explore this primitive remnant from the origins of the solar system, designed to study the asteroid and return a sample to Earth. Bennu is a dark, diminutive world, roughly the height of a skyscraper, and now the smallest body to be orbited by a spacecraft. Prior to arrival, it was known to have low thermal inertia, a characteristic of fine-grained materials like sand. An infrared spectrometer on OSIRIS-REx confirmed this property, leading scientists to expect a predominantly smooth surface. But the first close-up views of Bennu delivered a major surprise. In exquisite detail, the mission's cameras revealed an unrelenting rockscape dominated by boulders. By combining these images from OSIRIS-REx with its laser altimetry data, we can take a tour of Bennu's remarkable terrain. The first stop is Simurgh-Saxum. This prominent boulder defines the asteroid's prime meridian and serves as the basis of its coordinate system. In Persian mythology, the Simurgh is a large and benevolent bird and the possessor of all knowledge. Saxum is Latin for stone. To the northeast lies the largest boulder on Bennu. Measuring over 300 feet in length, Rock Saxum is a colossus longer than a football field. It is also rich in a type of iron oxide called magnetite, which was used by mariners as an early form of magnetic compass. In Arab folklore, the rock is an enormous bird of prey that can clasp elephants in its talons, as well as stranded sailors like the hero Sinbad. Continuing northeast over the equatorial ridge, we arrive at Gargoyle Saxum. This striking boulder is among the darkest on Bennu, though it clutches a much brighter rock that is about the size of a person. In medieval legend, gargoyles are dragon-like, winged monsters that can breathe fire and that guard cathedrals from evil spirits. Our next destination takes us far to the east. At the northern end of a small crater lies Ocypete-Saxum, a comparatively bright boulder measuring about 33 feet in diameter. Ocypete-Saxum is located near one of 3 sites where Bennu ejected small particles into space in early 2019, displaying its dynamic and evolving nature. In Greek mythology, Ocypete is one of the 3 harpies, the half-maiden, half-bird personifications of storm winds, who would carry evildoers away from the earth. In the creation stories of ancient Egypt, the universe began as a formless, endless expanse of water. From this primordial sea arose the primordial mound, Benben. It was upon this rock that the god Atum settled in the form of the Bennu bird and sent forth the call that shaped creation. The story of Benben harkens to the mounds of fertile silt that once emerged from the receding floodwaters of the Nile, and it provides a fitting namesake for the tallest boulder on Bennu. Protruding by over 70 feet, Benben Saxum is so tall that it was first detected from Earth. Now, we can appreciate this monumental feature in detail using data from OSIRIS-REx. The final stop on our tour is a cluster of exceptionally bright boulders scattered across the southern hemisphere. They bear the spectral fingerprint of pyroxene, a mineral found in igneous rock that is unlikely to have formed on Bennu. These boulders most likely originated on the large asteroid Vesta and were delivered to Bennu's parent body through meteoroid impacts. Although it is small in size, Asteroid BENNU has proved to be a fascinating world, abundant in geographic features that have defied our expectations. Thanks to OSIRIS-REx, we can now explore BENNU to uncover its composition, its evolution, and its ancient memories from the origins of the solar system.
If everything has gone right tonight, a little bit of BENNU will be coming back to Earth in 2023. So let's get one last visit with our social media desk. James, what's going on?
Yeah, Michelle, I've got goosebumps. I really can't even begin to fathom that we just tagged and collected a sample from this asteroid 200 million miles away. I know I'm going to want to relive the events that just unfolded tonight. I'm sure you will as well. So once again, we have that 360 video up on our NASA Guided YouTube page. Go check it out and put yourself right where the action just happened a couple minutes ago. It's truly mind-blowing stuff. I also want to check back in with that Twitter poll that we put out at the beginning of the broadcast, and we were asking you how much material you think we just got from Asteroid BENNU. So remember, we're looking for at least 60 grams, but that sample container can hold up to 2 kilograms. So you guys are saying that a candy bar size of sample? I like the optimism. Let's hope we actually pack that container to the max and bring all the sample back home. But any sample we get back is truly magical and will help us learn more about the solar system and our origins here. So keep at us on the hashtag to BENNU and back. We're excited to keep this conversation going as we look to bring that sample all the way back from BENNU here to Earth in 2023. So back to you, Michelle.
This is one of these evenings where it's such a privilege and a pleasure to be working for NASA and for the idea of scientific exploration. So what we've been doing all evening is seeing the joy, seeing these people that have worked on this for decades. But you have to remember there's a real reason we're going to look at these asteroids. We think we actually might be coming back with a baby picture of what the solar system was like, of what our chemistry was like billions of years ago. We're looking for our own origins out there, and that's why we've gone so far to bring a bit of BENNU back. This has been an incredible evening. The adrenaline is slowly beginning to slowly go down, and there's going to be a lot of celebration and a lot of work in the coming hours. So from Lockheed Martin Space here in Littleton, Colorado, I'm Dr. Michelle Thaler. Good night.
OSIRIS-REx is a NASA mission to explore near-Earth asteroid BENNU, a remnant from the dawn of the solar system, and to return a sample of BENNU to Earth. Pixel into a world, with OSIRIS-REx revealing its shape, rotation, and color for the first time. Now, after chasing its target for over 2 years, OSIRIS-REx is arriving at Asteroid BENNU. On December 3rd, it will fire its thrusters to match BENNU's velocity and begin its preliminary survey. OSIRIS-REx will pass high above the equator and the poles, measuring BENNU's position and mass, and refining its size,